To our tutorial part 9, the final art tutorial for the stats course that I'm currently teaching, but hopefully not my last. And this one's for the chapter 25 and 27 project, primarily focusing on chi-square tests. So we're going to use the data set MT-CARS, which is motor trend car road tests. Here's what the first few lines of data look like. And we're going to particularly, for this example, look at engine shape, whether it's V-shaped or straight. I have no idea what that means, but I needed a binary variable. And transition, whether or not it's an automatic or a manual, I do know what that means. So we're looking at vehicle shape versus automatic or manual. And we're going to make a 2x2 table of engine shape and the transmission type. And what we want to do is use this to make a mosaic plot comparing engine shape and whether the transition is automatic or manual. And then we're going to print our plot. We also want to figure out which engine is more likely to be manual. Is this different, statistically different? So we're going to take out a chi-square test. So first let's make a table. So here's our chi-squared table. 0, 0, right? This is row and this is column. So I'm going to have 0, 0. That means it is V-shaped and automatic. Here we have V-shaped and manual. Here I have straight and automatic, and then here we have straight and manual, right? So so we can make a mosaic plot of this data. So this is kind of showing how big it is. It was 12, 12 to 7, 6 to 7. Those are pretty close in size. It's saying to run a chi-square test, right? Chi-square tests whether there is a relationship between two data variables. So you have to put in your x and your y. The one thing we're going to do is we're going to put our correction to be false. We don't want it to correct our data. We aren't going to be using that in this class specifically. So I can run a chi-square test of my two data values, which is vehicle shape and type of transmission. We set correct equal to false. And so for this test, which I'm about to run, our null hypothesis is that there is no relationship between between motor shape and transmission, and our alternate is that there is a relationship between the motor shape and the transmission. So the degrees of freedom in this case is 1 because it's a 2x2 table, making our critical chi-squared value that I got from our book to be 6.63 at the 0.01 significance level. So let's run our test. So we got a p-value of 0.3409. That's not great. That's pretty high. So we're going to fail to reject our null hypothesis at the 0.01 significance level. Again, I would fail to reject as long as it's above 0.05. We want the odds of that happening by chance to be less than 1 out of 20. So just a little introduction into chi-squared tests. As always, the PDF and our markdown file are available in our Canvas course.